All right, today we're going to pull back the curtain on one of the most fundamental ideas in all of programming. Seriously, this thing powers pretty much every piece of tech you use. We are talking about functions.
So, to kick things off, I've got a little riddle for you. What do a recipe and a coffee maker have in common? Now, I know that sounds a little random, but trust me, the answer is the key to understanding, well, everything we're about to cover.
Believe it or not, they're both perfect examples of what programmers call a function. In the world of code, a function is just a small, reusable chunk of code that does three things. It takes an input, it does some work, and then it gives you an output. It's that simple, but man, is it powerful.
Okay, the easiest way to wrap your head around this is to think of a function as a simple little magic machine. You don't really need to know about all the complicated gears and wires turning on the inside. You just need to know what it's built to do.
And here's the cool part. Every single one of these machines works the exact same way, in three simple steps. First, you've got the input. For our coffee maker, that's the water and the coffee grounds. Second, you've got the process. The machine gets to work, heating the water, brewing the coffee. And third, you get the output, a perfect, delicious cup of coffee. See? Input, process, output. That is the core idea right there.
All right, so that's the big idea. But what does this magic machine actually look like when we're talking about code? I promise it's not as scary as it sounds. It's really just a set of instructions, like a recipe.
So here's step one, building the machine. That first line, def add a, b, that's just us giving our machine a name. We're calling it add, and creating two little slots for our inputs, which we're calling a and b. The line right below that, return a plus b, well, that's the instruction. It's just telling the machine, hey, whatever you get in those slots, just add them together.
Okay, the machine is built. Now for the fun part, using it. This next line of code is where we call our add machine to actually do its job. We're putting the number 3 into that A slot and the number 5 into the B slot.
And what do we get? Boom, the number 8. Our little add machine took the 3 and the 5, followed its one simple instruction, and spit out the answer. So you see, we just completed the whole cycle, an input of 3 and 5, a process of addition, and an output of 8.
Okay, that's pretty neat, right? But you might be wondering, so what? Why is this one simple idea so incredibly powerful? Why does every single programmer on Earth rely on it every single day? Well, it really comes down to two superpowers. First, they save you a ton of work. I mean, think about it. If you need to add numbers 100 times in your program, are you going to write that same logic out 100 times? No way. You just build one add machine and call it whenever you need it. It's brilliant. And second, they just keep everything so much cleaner and more organized. You know, instead of having this one gigantic, tangled mess of instructions, your program becomes this neat collection of little building blocks. Each block does one job perfectly, and you can just snap them together to build something way bigger and more complex.
And that's really the crucial point here. At the end of the day, functions are the Legos of all software. That app on your phone, the website you're looking at right now, even the software that's running a satellite up in space, it's all just made of these small, reusable machines all working together.
So there you have it. You now get one of the most important, fundamental concepts in all of technology. You basically know the secret to how all this complex software gets built. So the only question left is, what are you going to build?